Hey y'all, welcome back. Today we're working on our homework covering graphing rational functions. So we're going to take each of these functions, find all the important characteristics such as the x-intercepts, the y-intercept, and so on, and then we'll plot everything here on the graph. So what I've done is I've just kind of gone ahead and pre-filled out these little boxes with x-intercept, y-intercept, just to kind of save a little bit of time as we go through this. So I don't have to retype these for each individual problem. So your box though will be blank here, and you'll write this out. So let's go through all the steps on how you find these characteristics, and then we'll put them on the graph after we find everything. So let's start with the x-intercepts. To find the x-intercepts, you're going to set the numerator equal to 0. So what I'm going to do here is actually make a little, so this is where I'm going to show my work down here. And I'm going to make actually a little template here. So I'm actually going to pause the video real quick and include this on all the problems. Now, you don't have to be as organized as I am here. This is really just supposed to be your scratch work. You don't have to label this or anything. As long as you know how to find these, this is just going to help you, give you a place to do the algebra. So let's first start with the x-intercepts. And to find the x-intercepts, what we need to do is we need to set the numerator equal to 0 and solve. So we're going to have 3x plus 3 equals 0. And if we solve that by subtracting 3 and then dividing by 3, we'll get x equals -1. Okay? So we should have an x-intercept at -1, but before I write that here in my answer box and plot it on here, I do need to check for holes. So I'm going to just kind of wait on that. For the vertical asymptotes, we're going to do kind of the same thing, but we're going to set the denominator equal to 0 and then solve that. So here we would subtract 4 from both sides and then divide by 2, and so we should get -2 here. So we don't have any contradiction here, so that tells us there's actually going to be no hole here, so we don't need to worry about the hole equation because we don't have a common factor. So we can actually go ahead and say, hey, there's no holes. There is an x-intercept, and that's going to be at -1, 0, and there is going to be a vertical asymptote along the line x equals -2. So I'll start with that, and then we'll get into the y-intercept and the horizontal asymptote. So let's see here. Let's draw a little circle. Here, I guess I'll make it blue here. So let's see. We've got an x-intercept at -1, 0. That's going to be right about here. Let's make that a little smaller. And we've got a vertical asymptote at x equals -2. So for that, what I'm going to do is I'm just going to draw, typically if you're just using like a pencil or something, you would draw it as a dashed line so you can differentiate it from the rest of the graph. But because I'm working with colors here, what I'll do is I'll just do my asymptotes in a solid color as a solid line, but I'm going to use a different color so there's not really any confusion about whether or not that's part of the graph. So I do have a vertical asymptote at x equals -2, so I'm going to draw my little vertical asymptote here. And let's move on. So let's now find the y-intercept. So to find the y-intercept, what I need to do is substitute 0 everywhere where I see x. So this is going to be 3 times 0 plus 3, 2 times 0 plus 4. You really don't even need to show any work here, to be quite honest. It's just going to be 3 over 4. So we're going to have a y-intercept at 3 over 4, or I'm sorry, 0, 3 over 4. So really like 0.75 if that's easier for you to kind of visualize, but that's going to be right about here. Okay, now for the horizontal asymptote, you'll notice that both of the leading terms have a degree of 1, and when the degrees or the exponents here are the same, the horizontal asymptote is going to be equal to the ratio of the leading coefficients. So again, not really any work to do here. It's just going to be 3 over 2. So it is going to be y equals, and then 3/2. So 3/2 is about 1.5. I'm going to draw this horizontal asymptote as a green line, so there's no confusion about what, you know, that this is not actually part of the graph. So now to do the rest of the sketch, you know, if you're not really sure what's going to happen based on the multiplicity of these roots here, you can always do a number line. So I'm going to kind of show it both ways here, but as we go forward, I'm going to kind of abandon the number line because you don't really need it. And here for our scratch work, we didn't really need to show any work for this. So I'm going to just delete that. Give me some room for this number line that I'm going to construct here. So the sign of the function can only change at x-intercepts and vertical asymptotes, or holes. So the only values here I have are -1 and -2, so those are going to be the only numbers I include on my number line here. And I'm going to pick representatives. Oops, got these backwards. -2 is less than -1. What am I doing here? I'm going to pick representatives to figure out whether or not it's positive or negative on either side. I am expecting it to be positive up here because I don't have any x-intercepts down here, so that's kind of what I was referring to earlier, where there's like little, you know, some tricks you can get past using this number line, but this can still be helpful if you're just not really sure. So if I plug in like -10, for instance, what I'm going to get is a negative over a negative, which is positive, and so I know that my graph is going to be above the x-axis here. Now, you might be wondering, well, how do you know it's not like hiding in here somewhere? We don't really. We do need to check to make sure there's not an intersection with the horizontal asymptote, but we'll check that on the back end. Okay, for now, I'm going to go ahead and actually draw my curve here. So yeah, let's draw the curve. We don't need to be super precise about where it is, but it does need to approach the two asymptotes. Okay, and it can't be down here because we'd have to cross over the x-axis at some point. So that's how you know that it's not going to be down here. If I plug in something between -2 and -1, like let's say -1.5, then I'm going to get a negative value there. Okay, so this is going to be negative. Again, it's kind of, you really don't necessarily need to do this because hopefully you can kind of see what's going to, you know, once you do a bunch of these, you can kind of get a feel for what the graph is going to look like. But we do need to verify that we're not going to cross over that asymptote, so we'll do that last. So if I plug in a big number like 100 as my representative and I plug this in, I'm going to get a positive value, which is to be expected. Now I'm going to assume up front that I'm not going to cross the x-axis here. I'm sorry, I'm not going to cross the horizontal asymptote, but I don't, oh gosh, let's try to at least go through those 2 points I plotted. Get a little bit of precision here. Okay, well, that's going to be about as good as I can do with the mouse. But let's make sure we're not going to cross over and come back. So we do need to check to see, hey, are we going to cross the horizontal asymptote? So cross the horizontal asymptote? I don't know. So to find out whether or not you cross the horizontal asymptote, you need to know, is there any x value where the value of this function is 3/2? That is the horizontal asymptote. So what we're going to do is I'm going to just set up a little equation here. I'm going to give myself a little bit of room here and say that, you know, is this function, which is 3x plus 3 over, let's see, 2x plus 4, is that ever equal to 3/2? And it's possible that there's just no solution here, but let's find out, okay? And maybe there is a solution. Maybe it actually does cross the x-axis, or the horizontal asymptote. So I'm going to multiply, or I guess I can do some cross multiplication here. Use the cross products property. I'll get 2 times 3x plus 3 equals 3 times 2x plus 4. And I'm running out of room here, so I'm going to have to make this a little smaller for y'all so we can actually fit this work in here. Oh. Guess it doesn't want me to change the font size here. All right, so when I distribute the x, what I'm going to get is 6x plus 6 equals 6x plus 12, and take a look at what's happening here. So I've got this 6x on both sides. If I subtract 6x from both sides, what I get is 6 equals 12. This is a false statement, meaning there's no solution here. So because there's no solution here, that means that there is no place where we cross the horizontal asymptote. So the answer to cross the horizontal asymptote, no. And then that's because there is no solution to this equation. All right, so that means that our graph is good to go. We don't have to worry about like kind of fixing it. So yeah, we don't have to worry about that. All right, for number 2, we do have to do a little bit work up front. On number 1, we didn't have to factor because these are just linear binomials. I guess we could have factored out a 3 in the numerator and a 2 in the denominator, but that didn't really change anything as far as how we would work it out. For number 2, though, let's go ahead and factor these. So the numerator, and I guess I'll just write it right above here. It looks like we're going to have one of our factors be 2x plus or minus something, and then we've got another one that's just x plus or minus something. Now the plus or minus something has got to be numbers that multiply to give us negative 12. So I'm just going to try, you know what, I think I've got it. It's going to be 2x, let's see, plus 3 and x minus 4, and I think that checks out. Normally I would factor this by grouping, but just to save a little bit of time, I'll just go ahead and, these numbers are pretty small that you can just kind of think your way through it. But if you're having trouble factoring that, definitely advise factoring that by grouping. Now the denominator should be a little easier because the leading coefficient is 1, and the two factors here are going to be x plus 2 times x minus 4. Okay, so one thing I want to point out real quick, notice how we have an x minus 4 in both the numerator and the denominator. So that means we're going to have a whole, for sure at x equals positive 4. So we have something like 4 comma something, and we'll come back and figure out what that something is. But whenever you get this same factor in the numerator and the denominator, that tells you that there's definitely going to be a hole there. So let's go back to the x-intercepts. We are not going to include x minus 4 as a potential location for an x-intercept because we've got a hole there instead. So the only x-intercept is going to be found by setting 2x plus 3 equal to 0. And so if I subtract 3 and then divide by 2, I'm going to get x equals negative 3 over 2. Similarly, to find the vertical asymptote, I'm going to set the denominator equal to 0, but only the x plus 2 factor. Recall that the x minus 4 is causing a hole rather than a vertical asymptote. So I only get one vertical asymptote, and that's at negative 2. So my x-intercept is at negative 1.5, or negative 3/2, comma 0. That's a coordinate, and we'll plot that momentarily. And then my vertical asymptote, there's only one. It's going to be at x equals negative 2. So let's go ahead and mark those on the graph here. The vertical asymptote at x equals negative 2 is right here. Okay, and then the x-intercept is going to be at negative 3/2, so that's negative 1.5. So that's intersecting the x-axis right about here. Oh, nope. Let's try to make that actually look decent. Okay, so we've got the x-intercept, we've got the vertical asymptote. We have a hole that we need to find. You know what, let's just go ahead and do that now, and we'll come back to the y-intercept and horizontal asymptote. The nice thing about graphing these, as you're finding these characteristics, the order in which you find them is not really that important. You can kind of skip around to whatever seems easy at the time. The only thing that you really have to be careful of as far as like the order in which you find these is you want to be on the lookout for these holes. You don't want to go through the effort of finding an x-intercept of 4 and a vertical asymptote of 4 and realizing, hey, there's a problem there, those can't be, we've got a contradiction there, so it must be a hole. Just find the hole first. Not necessarily the y-coordinate, but, make sure to identify that there is a hole when you have a common factor. Now to find the y-coordinate of the hole, what we're going to do is we're going to rewrite this equation, but have these x minus 4's canceled out so that I could successfully plug in 4. You know, if I just plug in 4, you know, the way that it's written, I'm just going to get 0 over 0, which is undefined, and that's not going to give us the y-coordinate of the whole. To get the y-coordinate, we're going to plug in 4 to just like this first half, just the 2x plus 3 over x plus 2. So I'm going to do that down here. Oops. I guess what I'll do is I'll have to do this a little bit below to make this work. There we go. So the whole equation is going to be y equals, and I'm just going to cancel out or reduce to 1 these x minus 4 factors. So if I plug in 4 here, because I know the x coordinate of the whole is 4. So if I plug in 4 into here, what I'm going to get is 8 plus 3, which is 11, and then 4 plus 2 is 6. So yeah, we get 11 over 6. That's not very nice, but that's what it is. You don't always get lucky. So that's a little bit less than 2. Okay, so at 4 comma a little bit less than 2, we do have a hole there. So I'm going to go ahead and place that hole. Now, the way that you're going to sketch out the hole is you basically just draw a circle, but you don't fill it in. So 4 comma a little bit less than 2 here is going to be like roughly here. Okay, so it's going to kind of, and I can kind of see the graph coming together here. I'm guessing I'm going to have a horizontal asymptote somewhere up here, unless it crosses and comes back down. So let's actually figure out what that horizontal asymptote is. Before we do that, though, let's plot the y-intercept, and I think that'll really clear it up. So to find the y-intercept, we need to plug in 0 everywhere we see x. Again, you don't really have to do any algebra here. Just go back to the standard form equation and realize that every term that has an x is just going to go to 0. So if I plug in 0 here, 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 and here, then I'm just left with negative 12 over negative 8. So if my y-intercept is negative 12 over negative 8, I can reduce that to, let's see, I guess that'd be 3/2. So about exactly 1.5. So my coordinate here is going to be at 0, comma 3/2. Interesting little symmetry here, a little bit. All right, so anyway, let's go ahead and plot that out. We've got a y-intercept occurring right about, oh, we need to fill that in. We need to put it right about here. Okay, so we got my y-intercept, and now let's find the horizontal asymptote. So this one's kind of similar to number 1 in that the degrees of the numerator and the denominator are the same. So the horizontal asymptote is going to be at 2 over 1, and so 2 over 1 is just 1. So I get my horizontal asymptote at, oh wait, 2 over 1 is not 1. What am I talking about? 2 over 1 is 2. So I do get a horizontal asymptote at y equals 2. And I do need to check and make sure that I don't cross over it. So I think I might as well just do that now. Okay, so I want to know, is this equation right here, is it ever equal to 2? So let's find out. So I don't really need, let's kind of give myself a little bit more space to work with here. The horizontal asymptote, really no work to be done there. Okay, so do we cross the horizontal asymptote? Let's find out. We're going to set this equation. Here we go. And we're going to need to make this a little smaller, make it fit. I should have given you a lot more room to work this. I'm starting to realize. Okay, is this ever equal to 2? So yeah, this is going to be a little trickier. Now, we can reduce this to 1. We know that this is never going to equal 4, so we can just reduce this to 1 and get rid of those factors. And so let's find out, if I multiply both sides by x plus 2, then I'm going to get 2x plus 3 equals 2x plus 4. And hopefully you see right away that this is going to have no solution. So the answer to this question is going to be no. Okay, and you can see that if I subtract 2x from both sides, I'm going to get 3 equals 4, which is not true. Okay, so we know it doesn't cross the horizontal asymptote, so I can go ahead and at least sketch the right-hand portion of this graph. So I'm going to draw a little arrow here. We don't want to cross that vertical asymptote. That can never happen because we have a function. So I'm just going to do the best to kind of, now your line should kind of approach the asymptotes, and that's, basically what the asymptote does is it defines the long-term behavior of the graph. Okay, so we got the right-hand side, and to get the left-hand side, now if you were going to have a piece of the graph that was on, like, below this horizontal asymptote, you would have to cross the x-axis. But since we know that there are no x-intercepts on this side, we didn't find any here, then we can conclude that the graph is going to be above the horizontal asymptote. So notice I'm kind of bypassing the whole number line thing. You're allowed to do that as long as you understand, you just kind of think through logically, could it actually be on this side? And the answer here is no. So here's the graph for number 2. Yeah, and that's it. Let's move on to number 3. All right, so here on number 3, we've got x plus 1 over what looks to be a cubic. So the x plus 1 you don't need to worry about factoring that, but the x cubed, this thing we do need to go ahead and factor. So if I factor out an x as a GCF, I get x squared minus 2x minus 3. And then I can factor that a little further. Let me bring this up a little bit so you can see it. Kind of obfuscated by the grid here. Yeah, so, and then from here we can factor out this quadratic as x minus 3 times x plus 1. So let me go ahead and rewrite that. X plus 3 times x plus 1. Oh, nope, that should be minus 3 plus 1. Okay, what's going on here? Minus 3 plus 1, not plus 10. There we go. Okay, so I just want to make I want to do that factoring up front so that we don't have to worry about that later. Now we see that we have an x plus 1 over x plus 1, so we absolutely have a hole at x equals negative 1. So we do have a hole at negative 1 comma something. So we'll go back and fill that in. Did I fill that in on the other one? I think I did. Yeah, I did. Okay. All right, so now let's find the x-intercepts. Now, because negative 1 is going to be a hole, that leaves us with no remaining factors in the numerator other than just 1, right? Like if really it's just like 1 times x plus 1. So that means that there are going to be no x-intercepts here. So we don't have to find the x-intercepts. Now we do need to find the vertical asymptotes, and we can set each of the factors except for x plus 1 equal to 0. So if I have x times x minus 3 equals 0, then I'm going to be left with either x equals 0 or x equals 3. So I do have 2 vertical asymptotes. I've got x equals 0 as 1 and x equals 3. So I'm going to graph those with a vertical green line here like I've done with the other ones. So I've got now the fact that I have a vertical asymptote here actually tells me that I'm not going to have a y-intercept either. So no x-intercept and no y-intercept. Very interesting. Okay, so yeah, no, there can't be a y-intercept. If I plug in 0 here, I'm just going to get 0 over 0, which is undefined. So yeah, there's no y-intercept either. So the next thing we need to find is the horizontal asymptote. Now the degree on the denominator is larger than the degree on the numerator. So my horizontal asymptote has to be y equals 0. So let's go ahead and put that on here. Okay, and this is all we got here. So we don't have any clues as far as like, is it above or below? We do know that it's not going to cross over the asymptote because there's no x-intercepts, and there is, I mean, I guess it's possible we cross here at -1. Once we figure out where that hole is, though, if that's not 0, then we can rest assured that we're not going to cross over this asymptote. So what we need to do, since we don't have any clues to figure out, like, okay, well, is the graph above or below this horizontal asymptote, we're going to go ahead and we're going to create a number line here and pick our representatives and go from there. And that's kind of what you need to do if you don't have any clues. Clues being like, oh, I know that I don't have an x-intercept, so it's got to be up here or something like that. So let's go ahead and do our little number line here. The only numbers that should, like our partitions here, should be at 0 and 3. Since there's no x-intercept, there's nothing else to partition this real number line. So 0, 3, and I'm going to just substitute in some values here. If I plug in like a -10, and again, I'm going to ignore the x plus 1 over x plus 1. So what I really have here is like 1 over x times x minus 3. If it helps, maybe I'll write it down here. So this is going to be like my whole equation, which I'll need for later anyway. But what we can also use the whole equation for is to make our number line a little bit easier to complete. So my whole equation is going to be y equals 1 over x times x minus 3. So with this, now I can go ahead and substitute in my values, my representatives here. If I plug in like a -10, I'm going to get a 1 divided by a negative times a negative, so we're going to be positive here. If I substitute in a 1, then let's see, if I plug in a 1, I'm going to get a positive times a negative is negative. So we know we're going to be below the x-axis here. And then if I substitute in let's say a 5, then let's see here, a 5 would be positive, positive, so we're above the x-axis here. So the only real thing left to do is figure out where that hole is. And so what I need to do is I need to plug in -1 into this equation. So we're going to have a hole somewhere over here. It looks like it's going to be above the x-axis, but let's verify that that is the case. If I plug in -1, I get, let's see, this would be -1 times -4 would be 4, so 1/4. So the hole is at -1, 1/4. And the fact that that wasn't 0 tells me that we will not be crossing that horizontal asymptote. There's no other possible way to cross it. So that's actually kind of nice because then we don't have to go back and check for that. So -1, 1/4 is going to be my hole. So I'm going to plot that roughly like right here. And now I can just start sketching my graph out. So in this interval, I'm going to be above the x-axis. So I'm going to draw this, and it looks like it makes a pretty sharp turn here. Now, in between these intervals, I do not have an x-intercept, so I cannot cross over. And so what I'm going to have is kind of almost looks like a parabola here, but it's not really a parabola. But basically, the graph is going to approach these vertical asymptotes going down in either direction. I have to stay below the x-axis because I don't have an x-intercept, so that's how I know it's going to do something like that. What I don't know here is exactly where the turn happens. Whether it's up here like at -1 or much lower. I don't have any evidence to support that. If I want that amount of detail at this point, I just have to plug in some x values and figure out where it is. I'm not going to require you to do that because we're really just focused on the overall shape of the graph. Next year in calculus, you'll have some other techniques to find where these relative extremes are. So in this last interval, we know it's above the x-axis, so that last curve is going to look something like this. And really, it should look pretty similar to that one over to the left, just kind of mirrored, and no hole over here. So it's going to be something like this. All right. So there's number 3. Now let's take a look at number 4. Number 4, the numerator is linear, so no factoring to do there. But in the denominator, we probably want to factor this. It's a difference of 2 squares. We get x plus 2 times x minus 2. So no hole on this one, right? There's no factor. There's not going to be an x value that makes both the numerator and the denominator equal 0. So we can conclude immediately that there's no holes. So we don't have to worry about finding a hole equation, at least for now. We can skip that. All right, so the x-intercept is going to exist wherever the the numerator is 0. So here I'm going to say that negative 2x plus 1 is equal to 0. And so subtracting 1 and then dividing by negative 2 gives me 1/2. So I get an x-intercept at 1/2. For the vertical asymptote, I'm going to do something very similar here, except I'm going to set the denominator equal to 0. So I have either x plus 2 or x minus 2 is going to equal 0. And so it looks like I have 2 vertical asymptotes here. I get one at 2 and then another one at negative 2. So I'm going to put those up here just to document it, 1/2 comma 0 or 0.5 comma 0. And then my vertical asymptote is, well, I've got 2. I've got a vertical line at x equals negative 2, and then another one at x equals 2. So let's go ahead and plot those just to kind of get this going. I'm going to put my asymptotes at negative 2 and positive 2. I've got an x-intercept at 1/2 comma 0. So it's going to be roughly right about here. Okay, so for my y-intercept, I need to plug in 0 everywhere I see x. So I'm going to go back to the original function here and plug in 0 up here and down here. So these two terms are just 0. So I get plus 1 over negative 4. So my y-intercept here is going to be negative 1/4, comma 0. What am I doing here? 0, comma, negative 1/4. So I got my y-intercept right down here, negative 1/4. Kind of difficult to plot both of these because they're so close together here, but it's going to be right there. All right, so now the graph is starting to take shape here, but let's get that horizontal asymptote down. Now the degree on bottom is bigger, kind of like number 3, so that tells us that the horizontal asymptote is going to be at y equals 0. And then now we've got everything we need. So I'm going to draw that horizontal asymptote. Now since I've already found the x-intercepts and my horizontal asymptote is y equals 0, I don't need to check for any cross. I don't need to check to see if we're crossing the horizontal asymptote because I already found the only place where it actually happens, which is right here. Let's go ahead and start plotting this. I don't know if I'm above or below here, so I am going to have to do a number line. So I'm just going to construct a little number line over here. And I've got, it looks like 3 partitions. I've got one at negative 2. I've got one at, what is that, 1/2 is where the x-intercept is, and then I've got one at positive 2. So I'm going to pick a representative, let's say negative 10, and if I plug that in, I do get a positive value. If I plug in something like, well actually I already have a representative for this interval because I know where the y-intercept is, so let's just say it picks 0. I plug that in, I get negative 1/4, so I know we're negative here. Already had a representative. It's kind of nice. And then in between this little interval between 1/2 and 2, if I plug in something like 1, I'm going to get a positive value. So I know I'm going to be above the x-axis there. And if I plug in some very large number like 100, then because of this negative 2 times, this whole thing is going to be negative. So now I have all the pieces of my graph, and so now I can sketch it. above the x-axis in this first interval. Let's try to make that a little nicer. Now between this vertical asymptote and this x-intercept, I'm below the x-axis, so I have to go down. And then after I pass over the x-axis, I'm going to come up like this, because I'm positive there. And then finally, I am the value of the function is negative to the right of 2, so I know that the last piece has to be here. All right, so that's the first page. Let's take a look at number 5. So with number 5, it looks like we got a difference of 2 squares on the bottom. Let's go ahead and factor everything first, just like we would normally do. The numerator is going to factor to be x minus 4 times x minus 1. And then the denominator is going to be x plus 2 times x minus 2. So it looks like we're not going to have any holes on this one. We don't have a common factor here. So we can go ahead and say, hey, there's going to be no holes. So we do not need to find any holes here. We don't need to find the whole equation or anything like that. Let's go ahead and locate our x-intercepts, which are going to be where x minus 4 is 0 and x minus 1 is 0. So we do get 2 x-intercepts. So x equals 4 and x equals 1. So the 2 x-intercepts here are going to be at 4 comma 0 and 1 comma 0. I'm going to go ahead and plot those on here. So what was I using? Blue. So let's see here. 4 comma 0 would go right about here. And 1 comma 0 would be here. For my vertical asymptotes, I'm going to set the denominator equal to 0. So x plus 2 and x minus 2 equals 0. And that's going to give me x equals plus or minus 2. I guess it should technically be or here from an algebraic standpoint. But we do have 2 vertical asymptotes. We got one at x equals 2 and one equals negative 2. So I'm going to draw those again in green to show that these are not going to be, it's not really part of the graph here. It's just going to help guide the graph. So have a vertical asymptote at 2 and another one at negative 2. My y-intercept is going to be what I get when I plug in 0 to all of these. So I'm going to get 0 plus 0 plus 4. So I get 4 over negative 4, which is going to be negative 1. So I do have a y-intercept at 0, negative 1. For my horizontal asymptote, I do have a situation where the degrees are the same. The degree of the numerator is 2, the degree of the denominator is 2. So the horizontal asymptote here is going to be at y equals the ratio of the leading coefficients, which is 1 over 1. So it's just going to be y equals 1. And now I've got a bunch of, I got a lot going on here with my graph here. I do need to check and make sure to see, whether or not I'm crossing the I'm sorry, not the x-axis, but crossing the horizontal asymptote. So what I need to do is set my equation equal to 1 and find out whether or not that happens. So I want to set x squared minus 5x plus 4 divided by x squared minus 4. I'm going to set that equal to 1 to see if this ever happens. So I'm going to multiply both sides by x squared minus 4, and that's going to give me, make this a little smaller here. It's going to give me x squared minus 5x plus 4 equals x squared minus 4. So on here, I can subtract x squared from both sides, so these two are going to cancel each other out. And then I can subtract 4 from both sides. So here, let's just kind of do this in one step here. I'm going to actually leave the x squareds in there so that if you're reading this after the fact, you're not going to be wondering, hey, what happened to the x squareds? So yeah, the x squareds are going to cancel each other out. Yeah, that'll be a little better. And then I'm going to subtract 4 from either side to give me negative 5x equals, that'd be negative 8. So I do cross, it looks like, the horizontal asymptote when x is 8 over 5. Okay, so that's going to be about 1 point, let's see, 1 would be a 5 over 5, 6 over 5 would be 1.2, so 1.4, 1.6. So I know I've got a point here where I'm crossing the horizontal asymptote at x equals 1.6. Okay, so I kind of see what's going to happen here. It looks like what's going to happen is I'm going to come up like this, and then I'm going to go down like this. So I can actually fill out this part of the graph without having to worry about the number line. I don't have any more x-intercepts, so that gives me a big hint. Let's do this middle section first, because I have to go down like this, and then since I'm not going back up, there's no more places where I cross the horizontal asymptote, then that means I have to be going down as I approach that vertical asymptote of negative 2. Here I must be going back up, because I don't come back down. There's no x-intercept for me to cross through. On the right-hand side here, I clearly have to be below the asymptote, because in order for me to be above the asymptote, I couldn't have this x-intercept here. So that x-intercept is a huge clue. I know I'm not crossing the horizontal asymptote because I already found where I do cross the horizontal asymptote. It's not over here. It was just at this one place, this one location. And then over here to the left of this leftmost vertical asymptote, I do have to be above the horizontal asymptote because I don't have any more x-intercepts to work with. So since there's no x-intercepts to the left of this vertical asymptote, I can't be down here because I would have to cross over the x-axis if that were the case. So here's our graph for number 5. For number 6, and I think I'm going to move this over just to, well, not really anywhere for me to move it to. I guess I will just leave it there. For number 6, we've got a squared factor in the denominator. So, and we only have one linear factor in the numerator. So right away we can say there are no holes because there's no factors here, and it's already factored, so we don't need to worry about that. So we don't really care what the whole equation is here, and we don't really need to find those separately. So I'll just leave this as it is. So let's look at the x-intercepts. We're going to set the numerator equal to 0. That would be x plus 1 equals 0. So x is going to equal negative 1. So my x-intercept here is going to be at negative 1 comma 0. For my vertical asymptote, I'm going to set the denominator equal to 0. Now, what I have is x minus 3 squared equals 0. My first step here is going to be to take the square root of both sides. So I just get x minus 3 equals 0. And so I do get a vertical asymptote at x equals 3. So I'm going to draw my vertical line at x equals 3. My y-intercept is going to be what I get when I plug in 0 here and here. So I'm going to get 1 over It looks like if I plug in 0 here, 3 squared is going to be 9, so 1/9. So just barely off the x-axis there. So 0, comma 1/9. Yeah, so it's going to be right, like I said, just barely above the x-axis there. My horizontal asymptote, now this is not in standard form, so it could be a little deceiving here. But if I were to square this out and actually multiply it out, my leading term would be x squared. So this is a bigger on bottom situation where the degree on the denominator is larger. So my horizontal asymptote is going to be y equals 0. What's nice about the y equals 0 ones is you do not have to check to see whether or not we cross the horizontal asymptote, because the only time you can cross the horizontal asymptote is if you have an x-intercept. So I already know that I'm crossing the horizontal asymptote here. I don't have to find it separately. So this is all I've got. I don't know if I'm going to have to do an interval test over here and here and here. What it looks like, if I had to guess before doing the test, it looks like I'm coming down, crossing the horizontal asymptote, and then I'm probably going to go back up, which makes me think I'm going to possibly be down here. But because this is squared, now that's kind of making me think I'm going to be up here. So if I had to guess before I actually check, I'm going to guess I'm up here, and then this is going to be to below the x-axis down here. So let's see if that actually happens. I'm going to make my number line chart, which is going to help me decide where the function is, with my partitions being at -1, where that x-intercept is, and then 3. Where the vertical asymptote is. So if I plug in something like -10, I'm going to get a negative divided by a positive, which is negative. I know that denominator is going to be positive because it's actually always going to be positive. I'm squaring it, so whether or not the number inside here is positive or negative is irrelevant because I'm squaring. It's always going to be positive. So if I plug in something like 0, I'm going to get, which is going to be the y-intercept. I guess I already have that point. It's positive, so I know I'm going to be positive up here. So far, my instincts were right. I'm going to be above the x-axis between -1 and 3, and I'm going to be below the x-axis. So what I have to do here, and let me try to draw this with a smooth curve, is I'm going to pass through the y-intercept, the x-intercept crossing over, but then I have to curve back towards the horizontal asymptote. Remember, the horizontal asymptote is what's going to dictate the long-term end behavior. I'm having a heck of a time getting this right with a mouse. But the idea is you curve, and then we go through the horizontal asymptote, but then we kind of curve back towards it, okay? We don't know, we're not getting enough detail to see like how far down we go. That's something you'll do next year. But we do know that it crosses past the horizontal asymptote, but then it needs to go back to it because that's what the horizontal asymptote does. So I do know that I am positive between these two values. And then if I pick a number like 10, I'm going to get a positive of a positive, which is positive. So I am above the horizontal asymptote on the right-hand side, just like the left-hand side. Now I know this one's actually not going to cross over the x-axis because I do not have another x-intercept here for that to happen. So there's our graph for number 6. Let's take a look at number 7. Here on number 7, it's kind of set up the same way that number 8 was, where we've got a squared binomial in the denominator. So we can expect to have this same kind of behavior where the two sides, like where we meet at the vertical asymptote, we're going to be going in the same direction. Whether they're going up or down, we don't know yet. But we're not alternating between positive and negative infinity there when we have that even multiplicity. So here, it's already factored, and so we can see no holes here, so we don't need to worry about any of that. So yeah, there's no hole. So let's go ahead and find our x-intercepts first. So x plus 2 equals 0 is going to result with an x-intercept at -2. So my x-intercept is going to be -2, 0. And then for my vertical asymptotes, I've got a vertical asymptote. If I set x minus 1 equal to 0, it would be x minus 1 squared equals 0, but taking the square root of both sides is just going to result in x minus 1 equals 0. I get a vertical asymptote at x equals 1. So what else do we know here? We need to find the y-intercept, okay, by plugging in 0 into the x. So if I plug in 0 here and here, I get 2 over 1 squared is just 1. So I just get 2. So 0, 2 is going to be my y-intercept. And actually, that can be my representative for this interval in here. So I know for sure I'm going up like this. The vertical asymptote, oh, I already found that one. I just didn't put it in my little box here, is x equals 1. My horizontal asymptote, well, just like on number 6, the denominator has the larger degree. So I know my horizontal asymptote is going to be y equals 0, which, just like with the last one, means that I do not have to I don't have to check to see if I'm crossing the horizontal asymptote, because I already know I am right here. So there can't be any more crossings because I don't have any more x-intercepts. So that tells me that I already know the shape of the left-hand side here. And if my suspicion is correct that when we have an even multiplicity like this on a vertical asymptote, I suspect that on the right-hand side in this interval right here, I'm going to be positive. But we can check with our number line. So I'm going to go ahead and I already know what this is going to look like based on the information I have. It's going to look very similar to the last one where it crosses the x-axis and then heads back towards the asymptote. For the right-hand side, I am going to do a little test here. Okay, so just to make like a complete number line, I already know what's going on to the left of that asymptote, but let's say I didn't, if I wasn't sure about what's going on over here, I would create my partitions at -2 and 1 and plug in some representatives here. I would plug in like -10, which would be negative. And if I plug in something like 0, that's going to be, I already know what that's going to be, it's 2, so it's positive. But let's see what happens if I plug in something like 10. If I plug in positive 10, then I get a positive over positive, which is positive. So my suspicions are correct here, and that is that I am above the x-axis to the right of x equals 1. So this is going to come down, I don't know exactly where, but I know it's going to like ride that asymptote all the way to infinity. Never crossing over. There's number 7. We're done with that one. All right, number 8, and then I think that's the last one for this page. So let's do number 8. So here on number 8, we have really, I think, the simplest out of all the rational functions that we've graphed so far. I think this one's probably the easiest one. I'm not sure why we didn't lead with this one, but so this one doesn't have a whole lot going on. It doesn't have a hole for one, so we don't need to worry about finding the holes. There's just none. And there's actually going to be no x-intercepts either, right? There's nothing to set equal to 0. If we tried to set 1 equal to 0, 1 doesn't equal 0, so that would be a false statement, so we get no solution there from an algebraic standpoint. From a graphical standpoint, that just means there's no x-intercepts. The y-intercept, if I plug in 0 here, I'm going to get -1/5. So I'm going to have 0, -1/5. So just below the x-axis there. So right about here. The vertical asymptote is going to be where the denominator is 0. So for this particular one, we've got 1 at... What happened there? Well, here, let's just copy this. I'm not sure. Try to stay consistent here. That's weird. Why is it black over here? Oh, well, it doesn't matter. Anyway, we get x minus 5 equals 0. So x is just going to equal 5. So my vertical asymptote will be at x equal 5. And my horizontal asymptote, since the denominator is larger, is going to be, just like the last couple of problems had the same horizontal asymptote, it's going to be at 0. All right, there's no crossings, and so I know my, at least the left-hand side here, and there's no x-intercepts, so really the only partition here is at 5. So I know that from here, I'm going to be below that horizontal asymptote. And then to the right of the vertical asymptote, I'm guessing I'm going to be above here. I'll do a quick check. I'm not going to draw a number line or anything because I just need to check one value. But let's say I plug in 10. 1 divided by, yeah, I'm going to get positive, so I'm definitely going to be above the asymptote there. So there you go. There's 1 through 8. All the graphs are completed now. Let's take a look at page 3. All right, so here we are using the graph to come up with a function rule. So let's see what's going on here. We've got a, and I guess I'll just type it out here. We've got a vertical asymptote. Actually, we got 2 of them. Okay, we've got one at x equals 2 and x equals -2. And so what that means is that our denominator needs to be x plus 2 times x minus 2, which would equal, if I multiply those out, and it doesn't actually ask it for it in standard form, but if we did, it'd be x squared minus 4. So that would be the denominator. It doesn't look like there's any holes here, so I don't have to worry about including an extra factor in the numerator. Now, my horizontal asymptote is at y equals 1, so that means my leading coefficients should be the same. So I should have the same. It doesn't really matter what they are, but they could be like 1 and 1. So the same leading coefficients. And then I'm noticing that I have one intercept, specifically an x-intercept. I guess it's the x and the y-intercept now I'm thinking about it. The x-intercept at 0, 0. So that means that I've got just a factor of x. So, oops, can't spell there. Denominator. Wow, okay, let's fix that up. Okay, so you might think, okay, so let's see, my function should be y equals, or h of x. H of x equals x over x squared minus 4. However, if the denominator has the larger degree, then the horizontal asymptote is going to be at y equals 0. So I need these degrees to be the same. Okay, so not only do I know that the leading coefficients need to be the same, like 1 and 1, but I also know that the degrees need to be the same. I don't have another x-intercept to work with, so the only way for my numerator to have the same degree as the denominator and not alter any of the x-intercepts is to make this x squared. That way I still have my x-intercept at 0, but now I've got the same degrees, the same leading coefficients, so that'll work with my, my asymptotes and my intercepts and all that. So there's your function. It should be x squared over x squared minus 4. Now, part B here says we want an equation that would be identical to this, except it has a hole at x equals 3. So the fact that it has a hole at x equals 3 tells me that I should have a factor, and I'll just write this out, there should be a factor of x minus 3 in the numerator and denominator. Am I spelling it right this time? Denominator, yeah, okay. So I'm going to take this function h of x, and which it has no hole, and I'm going to inject a hole into it. So let's see how that will play out. So I'm going to multiply the top by x minus 3 because I need that one, and I need an x minus 3 on the bottom to make that hole. And yeah, there you go. There's the polynomial. Writing it like this is just fine. If you happen to multiply it out, you would get x cubed minus 3x squared over, what would that be? X cubed minus 3x squared minus 4x plus 12. So this would be in factored form, I guess, except for this one right here. And this would be in standard form. For number 10, which of the following is, looks like this is it. Just a little multiple choice question for you. Which is not a vertical asymptote of this function? So let's go ahead and factor out the denominator. That's really going to be what gives us our answer here. X squared plus x minus 12 would factor to be x times x plus 4 times x minus 3. Excuse me. Okay, so looks like I'm going to have vertical asymptote for sure at -4 and -3, positive 3. So you might be wondering, well, hey, 0 should be a vertical asymptote too. But no, the numerator also has x. So at x equals 0, we actually have a hole instead of a vertical asymptote. So that's going to be our answer here. And that's it for today. As always, if you have any extra questions or want me to clarify any of the work on this homework, or if you spot an error or something like that, let me know and we can get that fixed for you or explained. But other than that, y'all have a great day, and I'll see you next time.